Okay, so far we have done the electron configuration and the orbital diagram, right? Now we will discuss here the two situation of the electrons. So, or you can say that two type of the electrons. Okay, one are the electron those take part in the reaction. They are in the outermost shell, and other electrons those don't take part in the reaction. They remain in the core. Okay, so inside the atom. So two layer of the electron. So for example, let's say this is one, this is the nucleus, this is one cell, this is another cell, right? Of course the electron here, you have electron here also, you have electron here also. This electron will take part in the reaction. So electron in the higher energy level will take part in the reaction, right? Because that is outside and that can easily eject out or easily can donate or share or like that. Okay, so or other electrons are here, and these electrons whatever inside are said to be the core electron, and whatever in the higher energy levels are said to be the they are said to be the valence electron. Okay, so that's why two types of electron, valence electron and the core electron. So what are valence electron? Valence electrons are the electrons in the highest value of n or highest energy level. So and the occupied inner shell are the core electron. Okay, we will see that which are core and which are valence, how many valence electron in particular atom. So the core electron represent the noble gas electron configuration. Okay, so because they don't take part in the reaction, it's like the noble gas. The core electron represent the noble gas electron configuration, and including the noble gas configuration or the including the noble gas configuration is the condensed form of the electron configuration. Okay, condensed form of the electron configuration has the noble gas representation. So we will write in the noble gas form. Okay, now let's see, calculate first first of all let's see the valence electron of some atom, and then we will see the noble gas condensed electron configuration. Okay, so suppose that, for example, carbon has 6 electrons, right? So it has 1s2, 2s2, right, 2p2. Okay, so but what are the noble gas? Now let's see that. Let me show you the noble gas in the periodic table. Okay, look at that. These are the noble gases. Okay, helium, number of electron is 2 because its atomic number is 2. Neon, other is neon and its electron configuration is goes to the 2p6. Argon, krypton, xenon, rhenon, oganesium, like that. Okay, these are the noble gas. So look at that. The helium 1s2 is helium, right? So previously we wrote 1s2. So we wrote 1s2. So 1s2 is helium. That's why you can write that is a helium, and remaining is 2s2, 2p2. So look at that. In this electron configuration, what is the highest number of energy level? Highest energy level means the highest n is 2, right? This 2s and 2p has how many electrons? 2 plus 2, 4 electrons. That's why carbon has 4 valence electrons. 4 valence electron. Carbon has 4 valence electrons. Oxygen has number of electron 8. That's why 1s2, 2s2, 2p4, right? 2p4, 8 electron, right? So 1s2 is the helium and 2s2, 2p4. So highest energy level is 2. That's why 4 plus 2 valence electron, number of valence electron is equals to 6. Okay, similarly sodium, let's go to the sodium. Sodium is 11, right? 11, 1s2, 2s2, 2p6, 3s2, 3s1. Okay, so but this is the neon, right? This is the 1s2, 2s2, 2p6 is the 10 neon. Neon, that's why neon and 3s1. So highest energy level is 3. That's why number of valence electron is 1, because it has 1 valence electron. So similarly calcium, let's say calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is the calcium's electron configuration, right? So 10 to 12, 6, 18, 20. Okay, so look at that. But this is the argon up to 3p6, 18, 8, right? 10, 18 means argon. This is argon and 4s2. So calcium have how many valence electron? Highest level is 4th. That's why 2 valence electron is equals to 2. That's the calcium. Okay, so this is the calcium. So that's the core electron, and that's the valence electron, and that's the condense electron configuration. So you see that core electron, these are the core electrons, and 3s1, and that is the neon, right? So these are the core electron, and this is the valence electron. So now, so everything, lithium can be written as like that, sodium can be written as like that, we just write. Potassium can be written as like that, right? Beryllium can be written as like that. Calcium, argon 4s2, we already. Magnesium, neon 3s2, like that. Okay, so we have already discussed this one. So that's why now if we see that the electron configuration are given here, this is lithium is 2s1, beryllium is 2s2, like that. Okay, these are the electron configuration tables. So if you have a D, we have also given the example of D also, right? Chromium is the same thing. Okay, similarly like that we have to give that. Okay, so now the electrons are added to F cell, the L equals to 3, F orbital, there are 2L plus 1 equal to 7 value of ML, right? So you have FR14, okay? So because that, if L equals to 3, so look at that, N equals to 1, N equals to 2, L equals to 3 means F orbital, right? L equals to 3 means F orbital, okay? So L equal to 0, S. L equals to 1, P. L equals to 2, D. L equals to 3, F. If L equal to 3, ML will be what? ML will be minus 3, minus 3, minus 2, minus 1, 0, 1, 2, 3. Right? How many? 1, 2, 3, 4, 5, 6, 7. There are 7 suborbitals for F orbital, right? So how many total electrons then? One has 2, always 2, right? This has 2 electron. This representation minus 3 representation have 2, right? That's why 2. It can have also maximum 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 2, maximum 2, maximum 2, right? That's why 14 electron. F will have 14 electron. Okay. So let's see some examples are here. Copper and chromium. We already see that the chromium, right? This is the actual is this. Okay, and because the half filled orbital is more stable than the partially filled. That's why chromium we already studied that. This is the copper also. Copper also the same thing. Okay, the copper also same thing. Okay, argon 4s2 3d9, but 3d9 is what? Partially filled. If you take the 1 electron from here, it will become 10. It will be fulfilled. That's why partial fulfilled is most stable. Okay, so stability is fulfilled is stable than half filled is stable than partially filled. Okay, so the phosphorus, this is the example of phosphorus, right? And so that's it. We have finished this this chapter, and now and some periodic properties also, but I have removed the periodic property for your chapter, so that's why you just study up to the electron configuration. Okay, so the periodic table arranges atoms so that the elements with the same chemical and physical property are in the same group, right? But that's a periodic table. elements in the same group have the similar valence electron configuration. Okay, let me show you the valence electron. How do you know the valence electron? Okay, so look at that. So for the main group, it's not true for the other group. Okay, for the main group, so so let me show you the periodic table. This is dirty, and now let's go here. Okay, for the main group, okay, these groups, group 1, group 2, this and these groups, valence electrons are the number group. So this is valence electron of all of these is 1. 1, 1, 1, 1, 1, right? Valence electron is 1. These guys is valence electron 2, 2, 2, 2. These guys is valence electron 2. These guys will have just ignore this, ignore 1, ignore 1, ignore 1, ignore 1, and ignore 1. Okay. So these guys have valence electron 3. These guys have valence electron 4. These guys have valence electron 5. These have 6. These have 7. And these have 8. Like that. Okay. They have actually 0. So you can say that. Okay. Let's say that. What is that? So 1 is 2. Right. 2p. Say this is 8. See. 6 plus 2, 8. This is also 6 plus 2, something 8. This is 8. Like that. Okay. So anyway. So these are the novel. But these all are what? 3, 4, 5, 6, 7, 1, 2. These are the valence electron. But for the D1, okay, for the D level, so these transition element, we have the another method, okay. For the nth largest plus n minus 1th D orbitals, D electrons. That is for these guys. Okay, look at that. What is how many valence electron this guy has? Largest has 4s2, right? You have a electronic configuration for manganese is what is this? The argon 4s2 3d5, right? So yes, 4s2 3d5, yes. So argon is 18 plus 7, 25. So 4s2 3. Largest is 4s, right? Largest has how many electron? 2 electron plus nth largest, okay? Nth largest plus n minus 1th D means the largest is what? 4. 4s has 2 electron plus n minus 1 means 4 minus 1 is 3. 3d has how many? 5. That's why 5 plus 2 is 7. 7 valence electron. So you can get from here 5 plus 2, 7 valence electron. If I give you here this one, this has 7 plus 1, 8 electrons. This has just 10 electrons. Okay. This has 6 plus 1, 7 valence electrons. Like that. These guys just 8, these 2, both. So look at that. This transition element, this periodic table has given both. Largest and the n minus 1th D. But these has only given what? The 2s and 2p. Right? This is the 2, second, third, like that. Okay. So that's why D, if you have a D block elements, these are S block, they are P block, these guys are D block, these guys are F block. Okay. So that's why F block has what? Largest, nth largest plus n minus 1th F. Okay. And the D block has nth largest plus n minus 1 D. So these all 4 plus 1, 5. Like that. Okay. This is the valence electron. So that's why this is so present. If present n minus D subshell also. Okay. Those added. So the valence electron. So inner transition element or metallic element in this, the valence electrons after the last novel configuration in this element includes. So look at that here. Largest ns plus n minus 1th. Okay, n minus 1th D plus n minus 2 F. So these are F block. Just please ignore previous. Okay, F block. And the D block For the d block, nth s electron plus n minus 1 d electron. That is. So for example, this one, promethium, this is right. So that's why 6s electron are how many electrons? 6s electrons plus 6 minus 2, 4, right? 6 minus 2, n minus 2 f. 6. It don't have d, right? It don't have d. That's why n minus 2 f means n minus 2 means the 6 minus 2 tooth d electron. So 6s electron is how many? 2 plus 6 minus 2 d f electron is how many? 5. So this is equals to 7. If it has d also, then you have to add the d1 also. Okay. So this is the valence electron and core electron. Now let me repeat again. How do we calculate valence electron? Here, let me calculate. How do you calculate the? So let me see that. Okay, let me repeat that here. So, okay, one thing. So, electronic configuration of the anions or cations. Okay, guys. So it's the same as like, for example, sodium plus. Sodium plus means how many electrons? 10 electrons, right? Sodium minus means one more electron, plus means one less electron. That's why sodium plus is 10 electron. Now let's say the electron configuration. 1s2, 2s2, 2p6. Done. So sodium plus electronic configuration and the neons had the same electronic configuration. These two are said to be the isoelectronic. So similarly, let's say chlorine minus. Chlorine has 17. Chlorine minus has 18, right? Number of electron equals to 18. Chlorine minus has number of electron 18. So what will be? 1s2, 2s2, 2p6, 3s2, 3p6. Right? This is same as the argon. This is same as argon. Right? So argon's electronic configuration and chlorine minus is same. So for example, calcium plus 2. Calcium plus 2 has also how many electrons? 18 electrons. Because calcium plus means less, plus 1 means 1 less, plus 2 means 2 less. That's why its electronic configuration also will be same. So that is the isoelectronic. Okay, that's it. We have finished this chapter. Okay, so far we have studied here. In this last video, we have studied the valence electron and electronic configuration of the ions also. Okay, thank you so much.